Okay, y equals 15 minus 6x. So right now we're going through a practice problem involving substitution and solving systems of equations through substitution. So I just said step one, we want to first solve the system of equations by first solving for one of the variables and one of the equations. So I chose equation 2, and I decided to solve for y because y did not have a coefficient, so it's already by itself. So it's really easy to just say subtract 6x from both sides, and we get y equals 6x, 15 minus 6x. Okay, so check. And now I want to substitute this back into the first equation. So that's our step 2. Substitute the value you just solved for into the first equation. Okay. So we have 7x minus 2y equals negative 10. We can substitute in this equation. So y equals 15 minus 6x into this value for y. So I'm going to go ahead and do that. So that's our step 2. Minus 7x equal minus 2 times y. So we know y is equal to 15 minus 6x is equal to negative 10. Okay, so negative 7x minus 30 plus 12x equals negative 10. And I'll keep doing the math here because I'm running out of room. We combine like terms. So 12x minus 7x is 5x minus 30 equals negative 10x. We want to get x by itself, so I'm going to try to get rid of this 30 on this side by adding 30. Thirty minus 10 is 20. We get 5x is equal to 20. In order to isolate x, we're going to divide by 5. And we get x is equal to 4. Okay, so we just found the solution for x for this system. Is anyone still confused? It's okay if you are. I'll do it one more time more slowly. But is anyone confused on how I found that x was equal to 4? Okay, seems like people got that. So step number 3 is with the solution you found. So either x equals something or y equals something. Plug this back into your original equation. And it could be either equation 1 or 2. I'll just do equation 2, but you could plug it into either. So equation 2 is 6x plus y equals 15 plus y equals 15. Then we have x equals 4. So this is me just substituting in that step that we found from step 2. Okay, then we get 24 plus y equals 15. In order to isolate y, we'll subtract 24 from both sides. Okay. And then what does y equal? Or what is the solution that we get for y? Feel free to send it in the chat or just unmute. Yeah, exactly. So someone messaged me, they said -9. Yeah, that's our solution. And then I put a key here. So we got x equals 4 and y equals -9. Nice. So this is essentially the method for using substitution. So you can sort of use these three steps. So one is we want to solve for either variable x or y in either the equations that we got. I chose equation 2 because there's no coefficient on y. Second step is we want to substitute the value we just solved for in this equation. So remember, this is our step 2. I got that x equals 4. Last step is to plug in the solution we just found into one of our original equations. So I plugged it back into equation 2 just because I thought that was easier to do algebraically. And I got, so in order to write your solution, you can write it as a coordinate pair. So I like to do this notation. So 4, -9. Our solution is great. Okay. Any questions on how I found x, how I found y, or any of these sort of steps for this method? Okay. I will move on. If anyone would like extra practice, feel free to also do this practice problem, which asks about the elimination method. But I'll be moving on in the interest of time, and then we might come back to this if we have a little bit more time at the end. Okay. I'm going to do a very brief recap of what we did last time, just as a refresher, and also since I know some people couldn't be here. So remember, right now we learned about 3 different ways to solve linear systems of equations. So one, and I think the easiest way would just be to graph them. Number 2 would be through the method of substitution, and the third method would be the method of elimination. If we were to graph our systems of linear equations, we can have 3 distinct cases. So one is we do have a known and unique solution. So in the case where 2 lines intersect one time, we know that we have one solution for the system. Case number 2 with graphing is where there are no solutions. So if lines are parallel, we'll have no solutions because the lines will never intersect. And then lastly, you can have the case where the lines are actually the exact same. So they will have an infinite number of solutions. So you can imagine they intersect along an infinite number of points. We also learned about the elimination method as well. And remember this method, since I didn't get to do a practice problem, I'll do a quick refresher on this one as well. This method tried to eliminate a variable from each system by first sort of multiplying the equations by some number in order to, remember we would add equations. In order to, when we add equations, we would be able to isolate a variable more easily. So in this case, we multiply the top equation by 3, the bottom equation by 2. We got opposite coefficients for y. And we're able to easily just add equations up because we can do that. And we found x equals 2. Okay, Now, skipping along to new content. Let's see. I want to talk about the break-even point. Last time I kind of left you on a cliffhanger because I said that I mentioned that sometimes within mathematics, you'll be able to apply math to things that will make you money, so like business, entrepreneurship. Since I know somebody said that, I forget how this came up, but I think last week's icebreaker was something about what's a skill that you would like to be an expert in. So this is a way that we can apply our new skills and new knowledge with solving systems of equations into business. So if you ever join a company, you might join as a business analyst. So business analysts do things such as investigate if a company is profitable, if a company has revenue, and the sort of costs of a company. I would be very impressed if anybody knows this, but what is the difference between profit and revenue? How are these two things different? Yeah, Benjamin, what do you think?
I'm pretty sure like revenue is what you get before you factor in like expenses, and profit is after that, I think.
Mm-hmm. Yeah, perfect. So as sort of a quick review, again, you guys don't need to know this, but equation you can memorize for the future is revenue minus cost equals profits. So exactly. So revenue is sort of all the money you get in a business. And then profits are the money that you're left with after you subtract all the costs that it took to run your business. So as a very quick example, imagine that, imagine you're starting a new company, and for your company, you want to create cars. So let's say in your first year, you did really well, and you're able to have $100 million of revenue. Great. But you don't necessarily get $100 million in the bank at the end of the year because it costs you $50 million to make these cars, right? So at the end of the year, what you get to put back in the bank is just $50 million. So this would be your revenue minus your cost is equal to profit. Okay. Excuse my handwriting. Hopefully this is legible. Evaluating business plan, it's important to know at what sales level revenue and costs are expected to be equal. So the reason why we want to do this is because, again, remember our equation. I shouldn't have erased it, but revenue, I'll frame it this way. So profits equals revenue minus costs. So the break-even point is essentially the point at which, how do I phrase this? If revenue and costs are equal, so let's say revenue is 100 and costs are 100, then we get a profit of 0. So sometimes the sales level is referred to a break-even point. And then last economic term that I'll go through. So when we talk about costs, it's a little bit vague as to what that is. So as economists, we might sometimes talk about costs as fixed costs. So things that we aren't able to easily change. So for example, a fixed cost, let's say you want to build a car. Like a fixed cost might be the cost of buying machines, right? Because it might be like hard to change the, number of machines you have from one day to the next versus variable cost would be the things that are a little bit easier to control. So for example, let's say like the type of material that you use is a variable cost, something like that. So fixed costs are things that are not really easy to change. For example, how much you owe to buy like a land for a factory or the cost of the machines in the factory versus variable costs are things you can change a little bit more easily, such as from like one day to the next. So for example, it's very easy to like hire workers and fire workers even one day to the next. Okay, I forgot that I had this slide, but so fixed costs are the things that remain constant regardless of production levels. So example, like I mentioned, building rent, also advertising are usually fixed costs versus variable costs are things that vary with your level of production. So I mentioned raw materials or like the type of material that you used, as well as like hiring and firing workers. So this is a little bit more econ than math, but we'll go back to the math in a second. But does anybody have questions about fixed costs or variable costs? Okay, no questions, so I'm going to move on. Okay, so we want to determine a break-even point. So imagine that the business that we have here is handmade craft angels, so like little charms, right? So an artisan wants to sell her handmade craft angels online. She estimates that her material cost for each angel to be $3.50. As of January 2007, the online merchant craftmall.com charged a $14.95 per month fee for a Premier account, featuring up to 25 products. This is a little bit of a mouthful, but basically the cost that we have to be attentive to are the material costs. So the materials for each angel cost $3.50. And then also this merchant has to pay a fee for her website. So she also pays $14.95 per month for her website. So comparing her craft to similar crafts on the market, the artisan estimates that she can sell the craft angel for $9.95. So the question is, how many angels will she have to sell each month to break even? And at that production level, what will be her production cost, revenue, and profit? When we say break even, remember I mentioned how break even is kind of when revenue is equal to costs. So if profit equals revenue minus costs, if revenue is equal to costs, then revenue minus costs will be equal to 0, right? So a break-even point is essentially where revenue is not negative, or when it stops being negative. So when revenue starts to hit 0, then that's our break-even point, because you can sort of see revenue is even to cost, or revenue equals cost. Okay, so we'll have to answer this question of basically where does revenue equal cost? We can do this by building a system of equations. So go on the next slide. Okay, I kind of spoiled it. Sorry about that. But the cost equation for the craft angels is the sum of the variable costs. So remember the materials for each angel will cost $3.50. So let's say if I just ask you the question, if it costs you $3.50 to make every angel, how many dollars will it cost you to make 2 angels? You'll say, 3.5 times 2. How about 3 angels? 3.5 times 3. So that's what we're doing in this equation. We're saying for every angel that you build, so A, it'll cost you $3.50. So in order to find the material cost of an angel, you just multiply that angel number by the material cost. And additionally, remember that the fixed cost of having a website is $14.95. So this is a one-time payment. It doesn't matter how many angels you sell. Even if you sell just 0 angels, it still costs you $15 to have a website, which is actually true. If you guys ever try to have a website, you do have to pay for a name. So this is our cost equation. Any questions as to how we found it to be $350A plus $14.95? Okay, I'll give it a couple more seconds. I know some people already said that this looks good. Okay. Does anyone want to guess what so if this is our cost equation, what might be our revenue equation? So going back, remember that you can sell the angels for $9.95. So what do you think our revenue equation would be? Does anyone have any guesses? If each angel costs $9.95, or sorry, that you can sell each angel for $9.95, what's our revenue? Let's say if you just sell one angel for $9.95, what would our revenue be for just the sale of one angel? Anybody have any clue? I'll reveal it in a couple seconds, but if anybody, yeah. Okay. Someone said 645 per angel. That is very, very close, but not quite. I think you're thinking about income. So remember, revenue and income are a little bit different. So the revenue would actually be the number of angels that you have times the price that you sell them at. So another way a shortcut to thinking about the revenue equation is revenue is equal to price times quantity that you sell. So here our revenue equation is the sort of price that you're selling the angels at times the number of angels. Okay. Is anybody confused on how I found this revenue equation? Okay, no questions. So we'll move on. And remember, for break even, we want to find where revenue will equal cost. So we'll essentially set these two equations, so cost and revenue, equal to each other because that's our break even point. So remember, one of the ways we can solve a system is through graphing. So here is the graph of these two functions, and we can sort of see where this meets, right? Who thinks they can, doesn't need to be precise or 100% correct, but like what seems to be the solution for this system? You can sort of give it your best guess. Nobody wants to guess? What's our solution here? What does it kind of look like it is? Again, doesn't need to be precise because you can sort of like guess what the numbers are. Okay, I'll reveal on the next slide. So yeah, it seems to be around 2.3, 23. If I go to the previous slide, you can kind of see that. Okay. So again, because graphing is not always really precise, we can sort of get an estimate from this graph, but ultimately we'll be able to find the exact point of substitution, the exact point of intersection by using algebra. And then here, it's probably easiest to use substitution method instead of elimination method. So we'll do this. So again, we're trying to find where RA is equal to CA. We know revenue is the price of the angel times the quantity of the angel. We know cost is the cost of the angel times the quantity of the angel plus $14.95. Another equation for cost you can remember is cost is equal to variable cost plus fixed cost. So this is a variable cost because the value of this term depends on how big A is, or like how many angels you make. Versus this is a fixed cost because even if you sell 0 angels, you still have to pay around a $15 fee to have a website. So we'll combine like terms. So here we did 3.50A minus 3.50A on both sides. And we get 6.45A is equal to 14.95. And then we find that A is about equal to 2.318. And we can go back to our graph and verify that this is true. So if we go back, we can see that our point of intersection is around 2.3, which is great. We evaluate our A at A is equal to 2.318 and determine that the break-even point. So remember, the last step of substitution is to take the solution we just found, so A is equal to 2.318, and substitute that back into our original equation. Remember, this original equation was 9.95A. We solve for A, so we just substitute that back in. Alrighty. After that work, we find that the break-even point is where X is equal to 2.318 and Y is equal to 23.06. Any questions at all on how we found these values? Alrighty. So moving on then. Something important about this is, so algebraically, we found that the break-even point is 2.318, although you can't exactly sell 2.318 angels. Like you can sell 2 angels, you can sell 3 angels, but you can't sell like 2.5 angels because like nobody's going to buy half of an angel, or you can't sell 0.318 angel because like nobody's gonna buy a fractional angel. So once we get an algebraic answer, we also have to make sure that it actually makes sense in the real world. Because it doesn't make sense to have like a fraction of an angel, we're going to round this up since we know that if she sells 3 angels, we'll be able to have revenue be greater than cost. So in this case, because our real world example, so for example, she can't sell just 2 angels because this will not be the break-even point. Our costs would be greater than revenue. So she has to sell more than 2. So the closest, if we were to round up, the closest integer to 2.318 will be 3. So that's why we're saying 3 is our like a real break-even point. Although when we solved it algebraically, we saw that it was 2.318. Okay. Any other questions on this? Or is anyone confused why I'm saying 3 angels instead of 2.318 angels? Okay. The cost to produce and advertise 3 angels is, so we're going to plug in our solutions. Remember, we found like our real solution is x equals 3. So we're going to plug this back in, or sorry, a equals 3 for angel. So we're going to do 3.50, which is the what the material cost of an angel is plus our fixed cost. And we find that the cost will be 25.45. We know that the revenue is equal to the price of an object times how much of that object you sell, so price times quantity. So if we sell 3 angels and each angel costs 9.95, the total sale from our angels will be 29.85. So again, we know revenue is greater than cost, and profit is equal to revenue minus cost. So if revenue is greater than cost, this means that profit has to be positive. So it makes sense that our profit will be 4.40. The way we did this is we did 29.85 minus 25.45. And we got 4.4. So this is our total profit. Alrighty. Any questions at all on this? Okay. So I'll spin around actually, instead of introducing this new topic, so I'll introduce it really briefly, but I also want to go back and try out the elimination method, since we haven't been able to do that yet. Before we do that, does anybody still have questions on like what we mean when we say revenue, cost, or profit, or sort of how we were able to solve this equation? Okay. So last question from me. I will move on. So we've only talked about how to solve systems of 2 equations, but you can actually solve systems where there are 3 or more equations. So that's what I'll be talking about for the last couple of minutes. If you like this, then you will really like linear algebra, which is an advanced math topic that basically is focused on solving systems of very many equations. So you can learn how to solve systems of 3 equations or 4 equations or even 10 equations and more. Certain software lets you solve systems of equations of like 100 equations, 200 equations, and so on. But for now, let's start out by doing 3 or more. Okay. So for a system of 3 or more linear equations to have a solution, all of the lines must intersect at the same point. So you can imagine having 3 lines, so like this. This system of equation will have a solution at this point, but you can also have other cases where the lines do not intersect. So for example, here, notice how the lines do not all intersect. So the keyword is all at the same point. Here they intersect at 2 different points, but it's not all at 1 point. So this would also be an example of another system of equation that doesn't have any solutions because none of the lines intersect. The system will also not have a solution because the lines don't intersect at the same point. This is important. The fact that 2 lines intersect at a point, so A and B, so for example here and here, does not ensure that the third line will intersect the first 2 lines at the same point. Any questions? I think the last sentence is really important. So if anyone is confused on what I mean by that, please let me know. Alrighty. So I won't ask you to do this today, since I know I just introduced this, but to walk you through what it would look like to solve a system of 3 equations, I want to solve the following system of equations. So first, we'll find the point of intersection of the first 2 equations, and then check if that point is a solution in the third equation. So this is really neat because we can kind of ignore the last equation until the very end. So we can sort of use substitution, elimination, or graphing to find the solution x equals and y equals. And then once we're done with that, we can think about our third equation and plug in these 2 points that we found from the first 2 equations into this equation. And if these points make this equation true, then we know that these points also have to be a solution for the third equation. Okay. Does anybody have any questions on the method here? Okay, so here it actually shows you doing that. They find x, they find y, and then, oh no, y disappeared. Supposed to say y. They found x, they found y. Then they plug in their solution into the third equation to see if it also makes that equation true. So 8 is equal to 8, so the 0.31 will be a solution for a system of 3 equations. And if you graph it, you can sort of see that's true. Alrighty. So I'll go back to one of the questions we had on the Jamboard. So I walked through this a little bit fast, but you can sort of see how we can use the same method that we use to solve for systems of 2 equations, now for systems of 3 equations. I'll say the easiest method to use if you're asked to do this is always to graph it if you can. Again, if the lines all intersect at the same point, then that point will be a solution for this system. 3. Go back to our handy dandy Jamboard. So now we're going to do a little bit more practice like we did for our homework. So at the beginning of class, we did the substitution method. At the end, we'll try the elimination method. So let's see. So our first step, so step number 1 for elimination is multiply equation by factor. That will make it easier to get opposite coefficients on either x or y. So what I mean by that is we either want the coefficient on x to be -2 because in the equation 2 is +2, or we want the coefficient on y to be here to be the opposite of it here. So it's probably easier to try to get the first coefficient to be -2 instead of trying to change the y coefficients. So we'll go down that route. Okay. So we can multiply this first equation by -2. If we do that, we get -2x plus 4y equals to -30. And then we can rewrite our second equation. I didn't change anything. I'm just going to rewrite it. 2x plus 3y equals 2. Okay, and we can add these. So that's step 2, is add our equations and solve for one of the variables. -2x plus 2x is 0. 4y plus 3y is 7y. -30 plus 2 is -28. Who knows what? So we have 0 plus 7y equals -28. Who knows what y might be in this case? Yep. Thank you to everybody who answered. So we'll get y equals -4. Nice. Okay. And then last step for elimination, just like substitution, we're actually substitute this value back into one of the original equations. So we can substitute this value. Let's choose equation 1. So equation 1 is x minus 2y equals 15. X minus 2 times -4 equals 15. X plus 8 equals 15. Who knows what x will equal? What will x equal in this example? So x, maybe I might need to make this a little bit clearer. X plus 8 equals 15. Fifteen minus 8 is 7. Yep. Okay. So now we found x equals -4, y equals -4, x equals 7. our last step should always be to check our work. So I'm going to check using the graphing calculator to see what we get. So x minus 2y equals 15. Let me see. Equals 15. And 2x plus 3y equals 2. So notice how our solution is x equals 7, y equals -4. So x equals 7, y equals -4. So we know that this solution is a good one. So yeah, so our check was good. Okay, great job, everyone. So I'll do a very quick recap. So one, I would say you should be a bit more familiar with methods of substitution and elimination when solving systems of equations. Number two, you should now be familiar with terms including revenue, cost, and profits. And I'll also write down the sort of equations for you. So profit is equal to revenue minus cost. Revenue is equal to price times quantity. And cost is equal to variable cost plus fixed cost. We should also be familiar with break-even point. So remember, in a business, we have the break-even point where revenue is equal to costs, which this also means profits are 0. We should also understand or begin to understand how we can solve systems of more than 2 equations. One of these is graphically, and if we were to solve a system of 3 equations graphically, remember, we would need all of the lines to intersect at the same point. I was the teeniest bit off. I'm sorry about that. So there are a couple cases. So case 1. So there is one solution if all of the lines intersect at the same point. There are no or 0 solutions if all the lines are parallel to each other. And lastly, 3, there are 0 solutions also if the lines if all of the lines do not intersect at the same point. So again, for example, let's say you have 3 equations, so this, and this. Even though 2 of the lines intersect, because all 3 do not intersect at the same point, then you'll also have no solutions for a system of 3 equations. So that's how a system of 3 equations or more is different from a system of 2 equations. So yeah, so you guys actually learned so much today, and also got an understanding of sort of how to apply mathematics and this concept of systems of equations to economy and business. And if you ever want to run your own business, this type of maths will be really important. So yeah, so I'm going to post these slides to our Google Classroom. If anybody has any questions, please do reach out to me. And then keep an eye out. I'm going to post a really simple homework on the Google Classroom as well to complete before our next lesson. So I'm going to drop this link in the chat. I'll also post this right after, but I'll put it in the chat in case anyone wants to see it immediately. And I will stop the recording now as